So we've been looking at building a conversion factor chain. How many hours in 1 year? First of all, does anybody know? So do you? Did you calculate it already or did you have that memorized? And are you right? Let's find out. My strategy was I always write down what they gave me. What they gave me here in this case is 1 year. And the proper abbrev for year is an A for annually. Technically, you can't use a Y because that's yards in the US. If you use a Y, Morgan, you got the notes? Yep, you wrote stuff down. If you use a Y, I'm okay with it. I'm not going to take marks off, but I'm enough of a nerd. I'm going to do the proper abbrev. Okay. What can I convert years into? I would stay away from months. Now, why would I stay away from months? Because what would you go to after months? How many weeks in a month? It's not 4. Right? And well, no, it's inconsistent. Even if you went to days, how many days in a month? It's inconsistent. But there is something we can break years into. Somebody said weeks. It's not exactly 52 weeks either. What can we break it into? Days, because the year is defined as 365 days, even though that isn't quite accurate astronomically. It's how we do it chronologically. So, okay, where do I want years to go in my conversion factor to get it to cancel? On the bottom, days on the top, and it's going to be 365 and 1. What do I want to end up with? Hours. Oh, can I go from days to hours, Kevin? I can. How many hours in a day? So where am I going to put the days in my next conversion factor, Kevin? On the top or on the bottom? And I can go to hours, and it's 24. And Tyler, this is probably what you did intuitively. You went, oh, it's 365 times 24. But what I'm arguing again is this tells me it is times, not divided by or anything like that. Can you get your calculators out? Because I don't trust Tyler. Is it 8,760? On your quest, which is not going to happen this Friday, I'm not going to fit it in before the long weekend. I was hoping to, but it ain't going to happen. I'm going to give you, in fact, I'll even tell you, it'll be the last question on the quest. I'll give you some weird time, 32 decades, 17.2 centuries, and I'll ask you to convert it to something else weird, milliseconds or something. Not a problem. We'll just build a chain. So, number 8. How many seconds in 1 year? Does anybody have memorized, not have calculated, does anybody have memorized how many seconds are in 1 year? I haven't. I'm going to start out writing down what they gave me. 1 year. What could I go from years into? If I was really clever and paying attention, what could I go from years into? Don't be scared because on your conversion sheet, you might notice in the homework, oh, I did something up here that can save me 3 steps here. Don't be scared to reuse it. Keep your eyes open, pay attention. So I'm going to go to hours. Otherwise, I would go days to hours, but I can put years on the bottom, hours on the top, and it's apparently 8,760. Now we're in hours. Does anybody know how many seconds are in an hour? Some kids do memorize that one because it's a fairly easy one. If you haven't, you'll probably end up just out of laziness memorizing it because you'll see it here. So what can I go from hours into? Minutes? Hours on the bottom. I think I talked about this. Why can't I use an M as my abbrev for minutes? Meters, that's miles. Minutes is MIN. It's a 3-letter abbrev. 60 minutes, 1 hour. Evan, what can I go from minutes into? What's the conversion factor? How many minutes is how many seconds? 1 minute is? And again, my argument, Evan, last day was you've memorized all this stuff already. You don't need to memorize extra stuff. You can memorize 8,760 hours in a year. I got better things to put in my internal hard drive than that. I can derive it in 3 seconds. So it's going to be minutes right here, seconds here, 60 seconds. Who remembers numbers on top? What do we do mathematically? Add, subtract, multiply, or divide? Multiply if numbers are on the bottom. Here it's all ones on the bottom, so it's going to be 8760 times 60 times 60. How many seconds in a year? I know it's more than 500,000. That much I remember, but I don't remember much more than that. Sorry, 31 million. Yeah, way more than 500,000. I was mixing this up with something else. Can you read me the digits? 315, 36, and then 3 zeros. For large numbers, if you're not sure whether it's 31 million or 3 million, just read the digits, and that's honestly easier for me to check that and write it out anyhow. And then I put the commas in afterwards, so then I can realize, oh yeah, 31 million. Yeah, that's right, it's 31.5 million seconds per year. How many of those do you waste? So in summary, here's my conversion method. I write down what they gave me, and then in brackets it says as a 2-level fraction. I'll show you what I mean by that in just a second. I look at the units and I find a conversion factor with those units. Sometimes, Gabby, it'll be something I have memorized. Sometimes it'll be from my green formula sheet. Sometimes they'll give me the conversion factor in the question, like 2.2 pounds is 1 kilogram, like we did for the first exam. If the original units are on the top, where will they be in my conversion factor? If the original units are on the bottom, where will they be in my conversion factor? And then I like to cross out units as I go along so that I can see which units are left. That's my built-in error check, Nicole. I should end up with the units that I was trying to end up with. So if we have a table of conversion factors, turn the page. Here are some imperial units. Mission, just to help you stay awake. Can you read number 9 to me nice and loud, please? Yeah. How many centimeters in 1 mile? Anybody know? Probably not. So I'm going to start out writing down what they gave me. What did they give me? Not centimeters. They gave me 1 mile. So 1 mi. Looking at that chart of conversion factors, Bishon, what can I change miles into? Feet. So where is miles going to go? Top or bottom? What's going to go on the top then? And 5,820 is 1. Okay. Are we at centimeters yet? No? All right, Bishon, what can I change feet to? Oh, really? So feet's going to go on the bottom, inches on the top. All right, what's going to go next to each of the, how many inches is how many feet? So a 12 and a 1. If we stopped here, would be in inches. I want to get to centimeters. Oh, they gave me that. Okay. Where's inches going to go? On the? Really? Isn't it on the top already? I want it to go inches. What's going to go on the top? Centimeters. And what's the conversion factor? How many centimeters is how many inches? I've scrolled down. Is that centimeters or inches? You need to tell me. Okay, so the 2.54 goes here, and then 1 inch goes there. So it's going to be 5,280 times 12 times 2.54. Or I think there's even a decimal, isn't there? Okay, let me get my calculator up and running. 5820, whoop, too many, times 12 times 2.54. 177,393.6. Ben, you got? Okay. You have to be following along and typing in. If you're not, I'm coming at you. So I'm going to pause and you're going to go type this in. And then you're also going to write this down, but you can't be zoning out, my friend. 177,393.6 units, Bishon. Sorry to be grumpy with you, but easy way to follow along, follow on your calculator. Also helps you figure out how to type these in. You got that okay? Because you and I are going to do the next one together. If you didn't get this written down, remind me later, or you can get it from Kevin. But we're going to try example 10. I like example 10. I like example 10. Example 10 is a nice question. Why would I say that? Did you hear me say it's going to be on the test? Or you're the kind of student that notices when your teacher tends to emphasize things? Good, 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 good. What is 60 miles per hour in meters per second? When we type, we often use what I call slanty fractions on one line. When we write, if I could teach you one thing in math, make all of your fractions two-level fractions. I'll show you what I mean. Look up, don't write this down. If you write 60 mi/hour, I'm going to go cray-cray because it's tough to tell what's on the top and on the bottom. Instead, write this down. We're going to write down what they gave me, 60. I'm going to put MI on the top. I'm going to do a clear second level, and hours is on the bottom, so I can clearly see, Ben, what's on the top and what's on the bottom. Okay, so write that down. I've got a built-in error check because I'm a nerd. I happen to know that to go from miles per hour to meters per second, it's roughly divide by 2. I can already tell you the answer is going to be close to 30. That's just in my back pocket. If I get 3 or 17 or 80, I know I'm wrong. But then what we're going to need to do is change miles to meters and change hours to seconds. We're going to do them independently. Which one you want to do first? Hours to seconds or miles to meters? I don't care. Pick. Okay, so let's put a times. Where is hours in my original fraction? On the top or on the bottom? Where's it going to go in my conversion factor then? I want it to cancel, so yes. Do you happen to know how many hours are in a second or how many seconds are in an hour? Okay, what can I change hours to then? Yep. Minutes is going to go on the bottom, and it's 1 hour, 60 minutes. That 60 on the bottom means later on I'll be dividing by 60, but I'm not done yet. Now, if I stopped there, that would be miles per minute. I want seconds. So I need to now get rid of minutes. Where is minutes going to go in my next conversion factor, Ben? Yes, good. What's going to go on the bottom? What's the conversion factor? 1 minute, 60 seconds. Okay. This would be miles per second. We've taken care of the time unit. We managed to convert that to seconds. Now let's focus on the miles. What can I convert miles to? Tyler, what? You mean I have centimeters right here, and I can go from centimeters to meters fairly easy. It would not be wrong to go to feet, to inches, but you know what? We got this sitting right here. Let's use it. Good catch. So where is miles originally? On the top. Where's it going to go in my conversion factor? And what's going to go on the top? Centimeters. And the conversion factor is, don't round off, 177,393.6 to 1. Let me give myself a bit more room so you can see in the back there. Then now what? I want to get rid of centimeters. Can I go from centimeters to meters? Yes, I can. So where am I going to put centimeters? On the? Good. What's going to be on the top? Meters. Now we're doing the metric thing. The metric thing is powers of 10. Centi is 10 to the what? It's on your green sheet. Don't look at me. Where does the 10 to the negative 2 go? You don't memorize top or bottom. It will go where the centi isn't. The centi is on the bottom, so it's going to go on the top, right here. So you're going to go on your calculator, and I'm looking at you, Chief. 60 times 107, that number, times 10 to the negative 2, divided by 60, divided by 60. And I'm hoping you get an answer close to 30. 28 point something, 29 point something, 30 point something, 31 point something. Do I hope? Okay, let me pause the video for a second and I'll come help you. 29 point. I'm just going to go 29.6 meters per second, but you all had 29.5656. Sure. Mr. Dueck, why do you round off sometimes and why don't you round off sometimes? I'm being inconsistent here. I'm rounding off when I know I'm not going to use the answer to find another answer. I'm not rounding off because I knew I was going to use this in this next question. I didn't want to use a rounded off value, which you don't know. So I'm being a little bit inconsistent here, Tracy. Convert 3,500 gallons to milliliters. Morgan, what am I going to do first? 3500. Why can't I use that as my abbrev for gallons? Grams, so gallons is GA. All right. From that chart up there, what can I convert gallons into, Morgan? No, it's not there. It's on your white sheet. There's a chart on that page, I think. There's no imperial units on the green sheet. We're in the SI system, but you live close enough to the border that you'll see some of these. So I'm doing that. I can go from gallons to liters. Oh, okay. Because first of all, what can I go to? Quarts. So where am I going to put gallons? On the and quarts on the top. What's the conversion factor? How many quarts is how many gallons? Just read from the chart. What number is next to quarts? I can't hear you. No, it's not next to quarts. Right here, right? We're doing gallons and quarts. Don't be giving me liters. What number is next to quarts? Say 1. That's what I need because I don't have the chart in front of me. What number is next to gallons? That goes right here. Okay? Don't overcomplicate it. If we stopped here, we're in quarts. Morgan, what can we go from quarts into? Again, go look at the chart. I'm sure I gave you something we can turn it into. Will pints help us? Is there something else with quarts? Oh, and can I go from liters to milliliters? Yes, there's my path. Okay? So pints would have been a bad fork to go down. Where am I going to put quarts, Morgan, my friend? On the good. And liters, I'm going to do a cursive lowercase l, or you can do an uppercase L. What's the conversion factor? What number is next to, look at where it says quarts and liters in the same line. What number is next to the liters? 1. What number is next to the quarts? Yeah. Liter and a quart are almost the same size. Not quite. Okay. Am I done? No, I'm in liters. What do I want to be? Milliliters. Now we're going to do the metric thing, Morgan, my friend. So I'm going to put liters on the bottom, milliliters on the top, and now you're going to go to your green sheet and tell me the metric thing for milli. 10 to the what? Good. Where does the 10 to the negative 3, folks, go? How do you, sorry? How do you know where the milli isn't? You're not memorizing top or bottom for this particular one. It's, well, the milli is the 10 to the negative 3. I got to put it there. That's what makes that a 1. So on your calculator, it's going to end up being, Juliana, 3,500. Technically, times 1 times 1 times 1. Will you bother typing those in? No. It's going to be 3,500 divided by 0.25, divided by 1.0567, and divided by 10 to the negative 3. Try typing this in. I'll do it up here. Let's see if we get the same thing. Isn't that? I get 1324879.41. Yeah? Yeah? Colby, thumbs up, thumbs down. Okay, don't clear your calculator. Let me come look. So Where's a good spot to round off in my answer? When in doubt, go to 3 sig figs. And I'm not going to use this to find something else. So I'm going to write this in scientific notation. I'm going to go 1.3. I'm going to round off here. Is this 2 going to stay a 2 or become a 3? 1, 2, 3, 4, 5, 6, 7 milliliters. Few more, we're done. Next page over. So here is one of those 2-level fraction ones that I said I like. Convert 6.12 kilometers per hour to millimeters per minute. First thing I'm going to do, I'm not just going to write down what they gave me, but tracing, I'm going to write it as a 2-level fraction. Tracing, I need to change kilometers to millimeters. I need to change hours to minutes. Which one do you want to do first? Doesn't matter, pick. So where is hours right now on the, where is it going to go in my conversion factor? Good. What can I put on the bottom? Oh, can I go from hours to minutes? Oh, let's do that then. What's my conversion factor? 1 hour is equal to? Good. If I stop there, that's kilometers per minute. I would go 6.12 divided by 60. Not done yet. Now I got to get rid of kilometers. Where is it going to go? Yes, why? Because where is it originally? On, yep. And this here, our strategy was we're going to get rid of the kilometers and have just plain old meters, and then we'll bring in millimeters. It's going to be 2 steps. So I'm going to have just plain old meters, and I'm going to put the power of 10 for kilo. Where's the 10 to the third going to go? Where the kilo ain't. In this case, on the good. If I stop there, that would be meters per minute. I want millimeters per minute. So now I need to get rid of meters. I need to bring in millimeters. Millimeters, 10 to the? Where? Yes, because that's where the milli ain't. It's going to be 6.12, not using your scientific notation, Colby, using your, just typing the tens. 6.12 times 10 to the third power divided by 60 divided by 10 to the negative 3. It's going to look like this. 6.12 times 10 to the third power divided by 60 divided by 10 to the negative 3. Try typing that in on your own. And I have no idea what the answer is. Oh, 102,000 apparently. Double check me. So you got? Yep. Okay. So you're saying if you type all the numbers, you'll get the right answer? It might be worth just committing that one to memory, right? 102,000 millimeters per minute. One more weird one. I'm just making up some stupid numbers for practice. Convert 4,356 terameters per year to kilometers per hour. Both of these are speeds. So 4,356 terameters per year. I'll abbreviate year as annually again. Okay, we got this. Morgan, my friend, you're on deck again. We're going to change terameters to kilometers, and we're going to change years to hours. Which one do you want to do first? Pick. Okay. Where am I going to put years in my conversion factor? Well, where was it originally? On the, so it's going to go on the, yep. Oh, yes, turn back in your page. How many hours in 1 year? We have a conversion factor. We did that. Turn back a page. Okay, let's use that. So I can go straight to hours. 1 year, what was it? Read it to me, Morgan. Now, if I didn't have that, I would go from years to days and from days to hours. It's doable, but let's save ourselves a line. Okay. Now, we want to get rid of terameters. Oh, yeah, sorry. No, we're good. We got hours. You said we want to get rid of hours. I want hours, right? I'm good with that. I've taken years. I've changed it to hours. Now I want to take care of terameters and change it to kilometers. Step one is get rid of tera. So where is it going to go? Since it was on the top, it's going to go on the bottom, terameters. Tera, 10 to the 12. So just plain old meters on the top, and 10 to the 12 goes where the tera isn't, which in this case is on the top. This would be meters per hour. I want kilometers, kilometers per hour. So where is the meters going to go in my next conversion factor? What am I going to put on the top? I can't. You're right. I think I couldn't hear kilometers, but then I have to do the power of 10, the 10 to the. What's the 10 to the for kilo? Where's it going to go? Why? Because that's where the kilo isn't. So it's going to be 4356 times 10 to the 12th divided by 8760 divided by 10 to the third. I got a typo. What did I type wrong? I missed the 1. That'll do it. You get 4972607. Sorry, 49. Get that? Okay. Let's go 4.97 times 10 to something. One, two, three, four, five, six, 7, 8. And that is kilometers per hour. Let's win the lottery. This was the record last year. It might have just recently been broken. I got to look it up. But last year, Edwin Castro landed the largest single lottery jackpot ever in the US. He won $2.04 billion. How much is that? Let's spend it. Suppose he spends $10,000 per day. How many years will it take for him to spend the money? How can we do this? Well, the first thing is I'm going to write down the amount of money that they gave me, which is 2.04. And I'm going to show you a nice abbrev. Billion, I happen to know that that's 10 to the 9th, which is a lot less work than writing all the zeros. So Morgan, just go 2.04 times 10 to the 9th instead of bringing in all the zeros and all the commas. And what we're going to do next is we're going to divide this by $10,000. That will tell us how many days. So on your calculator, go 2.04. Colby, this will work as scientific notation because it looks like that. Scientific notation 9 divided by 10,000. This will tell us how many days it would take. It would take 204,000 days. How many years is that? Well, I think I divide by 365, but let's see. Days, years, 1 year. Yeah, you know what? The 365 is on the bottom. So go that number, use your answer button. You all have an answer button, by the way, right here. Or if you're a sharp, it might be alpha answer button or alpha equal sign, or on the TI second function equal sign. But you all have an answer button. It's worth using because you can save yourself retyping things. Divided by 365, and I get 559 years. If he spends $10,000 a day, can he spend that in his lifetime? Got to spend it faster. Okay. What if he spends $10,000 per hour? Well, let's again start off with 2.04 times 10 to the ninth. We'll divide again by 10,000, but this time we're going to get hours. It's 204,000 hours. Morgan, can I go from hours to years?
Hey, yes.
So where am I going to put hours on the... What's going to go here? Years. What's the conversion factor for hours to years?
Turn back on your paper and go look.
The 8760? Is that right? 1 year is 8760. So it's going to be 204,000 divided by 8760. If he spends $10,000 per hour, can he do that in his lifetime? What do you get? $233? 232 point. I got an extra zero, don't I? Never mind. That's why you're all looking at me weird. 23.3, is that right? I got a nod from Kalen. Is that what you got? Yeah. So this will work. Yeah. This is dollars per hour. And when you divide by a fraction, you flip it and multiply, which is why the hours ends up on the top on the next one. If you have a 3-level fraction, whatever's on the bottom of the 3rd level will end up on the top when you simplify. For what it's worth, if you want to get good at fractions. Okay. That work? Actually, he chose to receive a single payment of $997.6 million. So when you win a big lottery prize, the grand prize, generally what they say to you is, we're going to pay it out over 25 years in installments, or you can take a smaller sum up front. Why might you take the smaller sum up front? Why wouldn't you ask, hey, I'll take the whole prize over 25 years? Yeah, people think they might die before they get a chance to spend it, or you just have big plans and you want... Now, this is so ridiculously large, but like Lotto 649, I think the jackpot is supposed to hit something like 70 million this weekend or this week, which is like the record. You're not winning 70 million. You're winning 70 million spread out over 25 years, or we'll give you 12 million up front, or something is usually what they do, okay? How many years would it take him to spend this if he spent $10,000 per minute? Okay. So we're going to write down 997.6 million is 10 to the 6th. We're going to divide it by 10,000. This is Tyler dollars per minute. 997.6. Scientific notation button 6 divided by $10,000, and I get 99,760. And this is minutes. I want to convert that to years. Okay. Paul, what can I change minutes to? Can I go? I can go to hours. So minutes is going to go on the bottom, hours on the top. 1 hour is 60 minutes. And then what can I change hours to? Could go to days, but I think we have that conversion factor for years kicking around that we just used. Wasn't it 1 year was 8760? Here, you're going to get a small answer. Even $1 billion, which is what that nearly is, if you spend $10,000 per minute, you'll spend it fairly quickly. What do you get? It's a decimal, I think. Kevin, what'd you get? Is it 0.19 or point? Yeah, basically 0.19. Basically about 1/5 of a year. Okay, so you can't just spend money willy-nilly like crazy. You'll be through, if you spend $10,000 per minute, That would be $600,000 an hour, $500,000 an hour. That's going to add up pretty quick. You're going to go broke. So, right. You may have noticed, you may have read a surprising number of professional athletes when they retire are broke because they've never learned to be careful with their money. Next page. Put your pencils down. We're done the lesson. I think we're done the lesson, Mr. Dueck. Yeah, we're going to talk about some examples. I'm going to pause the video because maybe I can include the video in the video. We'll see. Enrico Fermi was a physicist who would often ask his students to solve a problem by making reasonable assumptions about unknown data. Enrico Fermi is a physics legend. He was on the original Manhattan Project that helped design the atomic bomb. In fact, his group were the first people to get a nuclear chain reaction going, a fission reaction. They did it underneath Chicago Stadium in Chicago City, which is kind of weird, but they did it there. But he was also very famous for, you could ask him an obscure question and he would say, I think it's about 10 to the 12th. I think it's about 10 to the 4th. I think it's about 10 to the negative 2. He didn't care about the front number. All he cared about was the 10 to the. We call that the order of magnitude. And you can get pretty good at this. Put your pencils down, look up. If you go to a physics conference, physics people will do this all the time if they're trying to figure something out. They don't care about being accurate. They just want to be ballpark in the 10 to the range. And it's not that hard when you get the hang of it.
Whether you like it or not, we use numbers every day. Some numbers, such as the speed of sound, are small and easy to work with. Other numbers, such as the speed of light, are much larger and cumbersome to work with. We can use scientific notation to express these larger numbers in a much more manageable format. So we can write 299,792,458 meters per second as 3.0 times 10 to the 8th meters per second. Correct scientific notation requires that the first term range in value so that it is greater than 1 but less than 10, and the second term represents the power of 10.
That's not new, hopefully. But the power of 10, we have a fancy name for that.
The order of magnitude by which we
multiply the order of magnitude.
First term. We can use the power of 10 as a tool in making quick estimations when we do not need or care for the exact value of a number. For example, the diameter of an atom is approximately 10 to the power of negative 12 meters. The height of a tree is approximately 10 to the power of 1 meter. The diameter of the Earth is approximately 10 to the power of 7 meters. The ability to use the power of 10 as an estimation tool can come in handy every now and again, like when you're trying to guess the number of M&Ms in a jar, but is also an essential skill in math and science, especially when dealing with what are known as Fermi problems. Fermi problems are named after the physicist Enrico Fermi, who was famous for making rapid order of magnitude estimations, or rapid estimations, with seemingly little available data. Fermi worked on the Manhattan Project in developing the atomic bomb, and when it was tested at the Trinity site in 1945, Fermi dropped a few pieces of paper during the blast and used the distance they traveled backwards as they fell to estimate the strength of the explosion as 10 kilotons of TNT, which is on the same order of magnitude as the actual value of 20 kilotons.
Quite famously, he stood with a piece of paper. When the shockwave hit him, he let it go and looked at how far back the paper landed based on the shockwave. It was about a 10 kiloton bomb. Did that all in his head. Very clever. So how do you do this? Here is a very famous Fermi problem.
One example of the classic Fermi estimation problem is to determine how many piano tuners there are in the city of Chicago, Illinois. At first, there seem to be so many unknowns that the problem appears to be unsolvable. That is the perfect application for our power of 10 estimation, as we don't need an exact answer. An estimation will work.
We're going to figure out how many piano tutors in the city of Chicago, which is kind of a bizarre, vague question, but we can actually get a pretty good estimate. Colby, head up, my friend.
We can start by determining how many people live in the city of Chicago. We know that it is a large city, but we may be unsure about exactly how many people live in the city. Are there 1 million people? 5 million people? This is the point in the problem where many people become frustrated with the uncertainty.
So what we do is we're going to use powers of 10. I'm going to call out powers of 10, and you tell me if I need to go bigger. Are there 10 people in Chicago or more? 100, 1,000, 100,000, million, 10 million. I think 10 million is too high because 10 million would include 60 million, 70 million. Those are the world's largest cities, and Chicago's not one of those. I'm going to say it's something in the millions. I'm going to say Chicago's population is 10 to the 6th, something times 10 to the 6th, but I'm going to use million, not 10 million as my starting point.
We can easily get through this by using the power of 10. We can estimate the magnitude of the population of Chicago as 10 to the power of 6. While this doesn't tell us exactly how many people live there, it serves as an accurate estimation for the actual population of just under 3 million people. So if there are approximately 10 to the 6 people in Chicago, how many pianos are there?
Question, how many pianos? Do you think there's a piano for every person? You know what? Is there a piano for 1 in 10 people or 1 in 100 people? Or 1 in 1,000 people. 1 in 1,000 people would say at this high school, only one home has a piano. I think more than that. 1 in 10 people would say in this classroom, 4 or 5 houses have a piano. I think that's too high. I'm going to argue roughly 1 in 100 people have a piano. So I'm going to take that million, I'm going to divide it by 100.
If we want to continue dealing with orders of magnitude, we can either say that 1 out of 10 or 1 out of 100 people own a piano. Given that our estimate of the population includes children and adults, we'll go with the latter estimate, which estimates that there are approximately 10 to the 4th or 10,000 pianos in Chicago.
Could be 20,000, could be 30,000, but all I know is I'm pretty sure it ends in 4 zeros. Okay. Now what? Well, someone needs to tune those pianos. Okay. How many pianos could a tuner tune in a year? Let's assume a piano gets tuned every year. 1, 10, 100, or 1,000. 1,000 pianos a year, that means the piano tuner is doing like 2 or 3 a day. I think that's high because it probably takes a while. 10 seems too low because you're not making a living. I'm going to guess on average a piano tuner tunes around 100 pianos a year. Might be 200, might be, I don't care. I just got the zeros right. So I'm going to take this number, I'm going to divide it by 100 to say,
with
well,
this many pianos,
on average,
how many piano tuners are there? We could begin the process of thinking about how often the pianos are tuned, how many pianos are tuned in one day, or how many days a piano tuner works. But that's not the point of rapid estimation. We instead think in orders of magnitude and say that a piano tuner tunes roughly 10 to the 2nd pianos in a given year, which is approximately a few hundred pianos. Given our previous estimate of 10 to the 4th pianos in Chicago and the estimate that each piano tuner can tune 10 to the 2nd pianos each year, we can say that there are approximately 10 to the 2nd piano tuners in Chicago.
I'm going to argue there's around 100-ish. Not 1,000, not 10. I'm telling you, that's closer.
Now I know what you must be thinking. How can all of these estimates produce a reasonable answer? Well, it's rather simple. In any Fermi problem, it is assumed that the overestimates and underestimates balance each other out and produce an estimation that is usually within 1 order of magnitude of the actual answer. In our case, we can confirm this by looking in the phone book for the number of piano tuners listed in Chicago. What do we find? 81.
Guessed 100, 81. Pretty close. And what's nice about the Fermi method is the more guesses you make, probably the more accurate you are. If you're making 15 or 20, if you're making 20 guesses, Jericho, probably 10 of them were too high and 10 of them were too low, and they'll cancel each other out, and you'll probably be pretty close. We do this all the time in computer simulations.
Pretty incredible given our order of magnitude estimation. But hey, that's the power of 10.
Couple more, we're done the lesson. Your homework you're going to get tomorrow. Sorry? Well, Wednesday, sorry, next class. That's what I meant to say. Still thinking semester. Hey, can you spot the error below? This was from a Twitter account. Some old crotchety person was trying to explain to young people that they don't understand finances and they don't save their money. So this is what they wrote. Would you rather get paid $1 million right now or $50 per month for the rest of your life? I'll take option B. That's what passive income is. You young people, find a way to make passive income. It'll change your life. $50 per month. How much is that per year? Can you go 50 times 12? Yeah, is it 600? How long might you live? Okay, can you go 600 times 100? Is that $1,000,000? This guy's an idiot. Take the $1,000,000. Please do not go for $50 a month. Dumb. No. This was from a fitness account. They were trying to do an inspirational message. And okay, I'm good with the inspirational message, but the math tracing was bad. They wrote, some days I'm just so tired, so I do the exercise tired. I don't pressure myself to make it perfect as long as I show. Here's what they said. Sometimes I only have 20 minutes and I make the most of it. 20 minutes of exercise every day equals over 1,000 hours of exercise a year. Does it? Let's see. 20 hours of exercise per day. So 20 minutes of exercise per day. How many days are there in a year? That's that many minutes. How would I go to hours? Divide by 60. It's 121 hours of that. It's not 1,000. They're off by an order of magnitude. Again, good for you. Yeah, get your exercise in, but please do the math right. This last one I lifted from Amazon. Who can tell me why this is stupid? This diagram is impossible. Why? What? How can this be 7.28 and this be 5.1? How can the longer side be smaller in magnitude than the shorter side? It's on your sheet. It's on. You can follow along. Sorry. Okay. All I know is I don't think I'm going to buy from that company. Homework. You're going to get a sheet next class with a bunch of these. On the sheet, I didn't attach the answers. Instead, I'll have a handwritten, because this fraction chain thing is weird. I'll have a handwritten showing all my steps answer key floating around online, in the classroom, and I'll also put it on pitmath.com. So your homework right now is make sure you're caught up. There's about 8 minutes left.